Correlation example 4. In this example, we're asked to do some coding in order to work out the correlation coefficient. We've got an identical advert being placed in some local newspapers, and we're looking for a link between the number of copies of the paper sold, which is P, that's been rounded to the nearest 500, and the number of phone calls that the company receives after the advert. So this is the data in terms of sales, this is the number of phone calls received, and we're asked to code the data using these two codings here. So for the X values, we're going to take whatever the number of copies was, subtract 30,000 and divide by 500. So if you do that for each of these values on the top row, you'll be able to fill in the corresponding values here. To do the coding for the second row, y, our new variable, is r minus 500. So whatever the number of phone calls was, this row, you take off 500 and put each value in here. So if you pause the video at this point and work out the data, and then we'll work out the correlation coefficient. So if you've done that, see if you get the same values that I'm putting into the table here. Minus 17, 72, minus 2, minus 102, 4, 65, 7, 171, and 25 and 89. So they're the coded values. We're going to work out a correlation coefficient now using these values, x and y. So part B asks us to use the coded values to find sigma x, sigma x squared, sigma y squared, and sigma xy. In the usual way that we've done in other examples, it's the sum of each individual x value, square them first, the x values, then add them up. Same for the y's, and then for the bottom one you multiply each x by the corresponding y and add up as you go along. So again, if you pause the video at this point and then see if you get the same values as me. So for sigma y, I got 151, sigma y squared, 77711, sigma xy, 5830, and we may as well write down the value of n. I think it was 6 pounds. Using these answers, we're asked to calculate the product moment correlation coefficient. So we're going to need to work out SXX first. That's sigma x squared minus sigma x all squared over n. So if we work that out, that's 1467 minus, put some brackets in here, minus 5 squared over 6. And when I work that out, I get 1462.83 recurring. This is one of those moments where you might want to store that in the memory of your calculator. SYY is sigma y squared minus sigma y all squared over n. And if we work that out, that's 77711 minus 151 squared over 6. And I got for that 73910.83. Again, possibly store it in your calculator. Next one, I'll do it over here, SXY, sigma xy minus sigma x, sigma y over n. Notice how every time I'm writing out the formula and I'm showing which numbers I'm substituting in where. That's what the examiner's looking for when they're looking for your method. So although it is a little bit monotonous and you think, I'll just type it into my calculator, it's actually better to write out the method to make sure you're showing your method clearly. Okay, so they're the three components that we need in order to work out R. R is SXY over square root SXX SYY. So if we substitute them in, SXY on the top and on the bottom SXX and SYY multiplied together And if we work all of that out, it works out to be 0.573 to three significant figures. Okay. The last part of the question says, give an interpretation of your coefficient in this context. So remember, if it says describe, that's maths words, and if it's interpret, that means in context. Well, this is a reasonable correlation. I'd prefer it to be closer to 1 in order to draw a very positive conclusion in order to be certain. However, I would say there is a reasonable correlation and it's positive. Generally, we might say, generally, greater sales lead to larger numbers of phone calls. Again, I'd be more convinced by that link if we were getting up towards 0.7, 0.8. Notice how there, when I got my final answer for the correlation coefficient, I didn't have to decode it. And you might want to write that down at the side of your notes. There's no decoding required when you're doing this, because basically all we've done actually is rescale the axes. We've subtracted 30,000, that would move all the points to the left, divided by 500, that would make them look as if they were closer together. But remember, you're not looking for how close together the x's are, you're looking for a link between the x's and the y's. Similarly, if you take 500 off each y value, all you're doing is moving them down vertically, but you're not at any point changing the link between the two variables, so you don't need to decode on this sort of example.